Good morning, Pac-Man.
Hello everyone, thank you for being here today. This video will introduce our approaches for Pac-Man capture the flag. In this context, we apply 4 techniques, including approximate Q learning, heuristic, Monte Carlo tree search, and decision trees. In the first approach, we decided to use approximate Q learning as our offense strategy, simply because it has a good performance in theory. The defense strategy is heuristic function. Basically, the defense agent will moving towards a random entrance using heuristic function. Entrance is defined as a point where our ghost will become Pac-Man if moving beyond that point. Once a food grade is eaten, the defender will move towards the position of eaten food and stay at this position. If the defender detects the enemy during his way to the eaten food, the defender will chase the enemy Pac-Man instead of moving towards the food. For offensive agents, it will select the action that has the largest Q value. We select 8 features to train the model, and they are shown in the slides. Well, for the challenges we have during the implementation, the first one is it's hard to simply use linear combinations of features to simulate the real game. The second one is it's going to need a long time of training to have a good performance, and we do not have enough time. For the future improvements, we could let the defense agents involved in the attack to eat more food. For the second approach, Monte Carlo tree search could be a reasonable approach because unknown states and the state space is really large. We will fully extend the root node by doing Monte Carlo tree search for each child node. The simulation will detect the food and capsule within 4 squares. It's possible that the simulation of child nodes give the same result, and Monte Carlo tree search will randomly choose one action. For example, at the beginning of the game, there are no food or capsule nearby. The Pac-Man will move randomly. Therefore, heuristic function is applied to find the optimal path. Also, the performance of defensive agent in the last approach is not impressive. We decided to try 2 offensive agents to see how it works. However, after inspection of several games, we find out that there are problems in the current approach. Next part is our Monte Carlo tree search workflow, which is shown in the slide. Have a quick look and we will head to the challenge and improvement of approach 2. The first one is Pac-Man will eat a capsule where there's no ghost chasing him, which is totally unnecessary. The second one is the Pac-Man is too greedy and get caught by a ghost. The third one is Pac-Man might stuck with enemy, which means just keep moving forward and backward. The fourth one is there are 2 offensive agents moving towards the same target, which is not efficiency enough. Therefore, they apply a decision tree to handle the challenges. For the future improvements, reading more information about layout can help our agent to make a better decision when it is facing a deep corner or other traps. The second one is setting a suicide mechanism for agent when the way back home is blocked by enemy ghosts, so that the food can be eaten by other teammates. The third one is to handle the situations that one ghost blocks the way of 2 offensive agents. We could let one agent to attract the attention of the ghost to handle this. Here is the demo section. Demo 1 shows that in approach 1, offensive Pac-Man is able to move towards the target, escape from ghosts, and return home when carrying 3 food. However, this strategy is too conservative and does not perform well. Demo 2 shows that in approach 1, the defensive agent is able to move to a random entrance at the beginning, and chasing invader will be the top priority. Approach 1 has 35 win rate against the staff team, which is not impressive. Demo 3 shows 2 cases that our defense agent should get involved in the attack. The first one is capsule is eaten by the enemy. It's no use to employ any kind of defending. The second one is when both enemy agents are eaten by our defensive agent. Enemy will take some time to our field. The defensive agent should attack during this period of time. Also, this is one of the motivations for us to use two offensive agents. The rest demos show how we apply decision trees to help agents overcome the challenge. Demo 4 shows that how we modify our offensive strategy from too greedy to a suitable level by applying a decision tree. This has a better performance than the conservative strategy in approach 1. Demo 5 shows that our agents will not move towards the same target at the beginning because we are setting two different targets for them. However, the agents could still move to the same targets later, and this could be a disadvantage of the approach 2. Demo 6 shows that the Pac-Man will switch the target field to avoid stacking with the enemy ghost. However, switch the target field cannot guarantee to solve this problem. Demo 7 shows that the agent will only eat the capsule when it is being chased by a ghost, which improves the efficiency of the attacking agents. The win rate of approach 2 against staff team is 68%. Thank you for watching this video.